Hello, welcome. I'm Bill Wake. We're here working on an old game from the 1980s I'm calling Blocked. It's really an imitation of the commercial game Breakout, trademark somebody. And let's get over there and see the code. All right, so we've done a lot of work to take code that was very unstructured looking to start with. Let's get the original code up here. Okay, so this is the old 1980s style basic. You've got for loops and go subs and if statements and I don't know. That's about it for control flow. So it's all built on that. We took this, we transliterated line by line and sort of a state machine to work its way through the line numbers. That's our starting point, and let's see our current state. All right, let's go to the top. Okay, got a lot of constants, a lot of variables. We still haven't worked out every use of this. All right, but here's our main loop blocked. Okay, so we set up a paddle. We've got horizontal and vertical, which sort of together form the vector of where the ball is starting. We've got the score. It's kind of a golf style. You count down every time you bust out a brick. Okay, draw an initial screen. We do this little check around the first time to not delay any. Then every loop is move the paddle twice, move the ball, and we keep doing this until the ball is until it's greater or equal greater than the bottom right corner. So if the ball bounces off the screen, there's a little video memory that's excess compared to what we can see, and it bounces an extra row or column over there. Actually, it shouldn't do columns, but it'll bounce into the to the row beneath our paddle, and we'll detect that and exit the game. And at the end of the game, we'll turn the ball back into a space and print score. We pulled out some methods so we can draw the initial screen is draw the top, draw the sides, draw the blocks. And I think that's clear enough. I'm going to separate them like that. Okay. We got lots of 22s and 23s throughout. The 6, 0 to 6, that's saying we're drawing 7 rows of blocks. Okay. The keyboard stuff is really ugly. All right, so that's this horrible looking stuff. 57088. Sad, but now I remember that pretty well. You're giving it a bit constant that tells it which rows to turn on, and there's a matrix corresponding to your keyboard, so it turns on certain rows, and then when it does the peak, it reads the columns for that. So if there's a key down, then a connection is either made or broken, and you get it back. And if it's 127, which is not 128, flip the bits for that. Then we're moving left, paddle -1. If it's this corresponds to an X. If it's a C, not 64, then we move to the right. And then if it's 253, which is not 2 or a comma, then we add some jitter. So this prevents us, if we cleared out a bunch of stuff and we had our paddle on the bottom in the middle and the ball was bouncing left side top, right side back to your paddle, there's nothing there that's going to make it go away or get off that path. Okay, so a little bit of jitter shifts it over a cell or two and gets it moving somewhere else. Okay, let's see. Next big subject was moving the ball. We poke a space, so wherever the ball is, we clear it out. We move it vertically once, move it horizontally once, and then we poke the ball character there. So that's the move. Okay, I guess the ball always moves one or more squares. Well, it always moves either vertically and or horizontally. The horizontal is always either 1 + 1 - 1, the vector for that, and the vertical is always plus or minus a row, which is 32 apart. All right, so moving vertically, here's a use of X. Okay, we calculate the vertical position. Where would the ball be moving up one? And if that is a space, then we can move the ball there. So it moves up. And if it's not a space, it's either a wall or a block or a paddle. I guess it won't be a paddle moving up, but vertical can be up or down. Okay, so it could be a paddle. If it's a block, then we're going to, whatever it hits, we're going to bounce the other way. And if it happens to hit a block, if that puts us hitting a block, we'll write a space where the block used to be. Okay. And decrement the score 1, so you get credit for one more thing. What's interesting here is X is actually the Y position. It's a quirk of the old code. We haven't addressed it. Okay, moving horizontally is somewhat similar. You take the ball, add the horizontal space, and if the place you want to move is empty, so it's kind of a blank part of the board, you just move there. Otherwise, you flip the horizontal vector. In other words, otherwise it's hit something, flip it horizontally, and write a space character where it is if it's a block. Okay, so what this tells me, which may or may not be intentional, I guess it probably is. You can hit both. Okay, so you can clear out a space above you, and then say it's moving this way, it clears out you clear out a block above you, it clears out another block next to you. So you actually get 2 chances to hit a block. Okay. And otherwise, I think we're good. All right. So all we've done, I mean, maybe I shouldn't say all, but what we've done is we've turned it from a basic program into kind of an ugly Swift program with still some leftover stuff here with the keyboards. Okay, with the keys. So I would like to take care of that. What else? I forget what I called it. Keys and constants. Okay. Well, we definitely want to deal with the keys. And then these constants, they're just, I don't know. They're all functions of either the screen height or the screen width. And you can't really tell because it's a 24 by 24 screen. Okay. So position 0 has a side wall. Position 23 has a side wall. That's the way this is only 22. Okay. And let's see. We do have tests, very, very minimal tests. And they're kind of, I guess they're a pin down test. We don't care what it does. We just want to make sure we haven't changed anything. All right. The first test just starts the game and lets the ball bounce around until it bounces past the paddle, and then boom, it's done. The next one, it actually moves the paddle to the right. So it says start moving to the right, and every turn it moves 2 more squares to the right, and then eventually the ball bounces off screen and you're done. Okay, and so what we do is we take the screen, we run this fingerprint thing that gives us a secure hash code, and we've saved the hash code. Very, very primitive. It doesn't cover everything, but it's kind of enough to keep us mostly safe. Not perfectly safe. All right, let's see if I can run these. I thought I did, but it didn't actually. All right, so what I anticipate doing is I'd like to at least deal with the keyboard stuff a bit and the constants that are still left. The constants, I'd like to deal with the keyboard. I mean, this, I'd like to find a better way to do that. Yeah, I really would. All right. And then, I got other stuff like this. Nobody sees X afterwards. All we're doing, we are modifying the ball and the vertical. Okay. But yeah, these routines are so similar. All right, the test ran. All right, let's at least rename this to Y. And I don't know. It's really not a Y. It's the um probably it's like the next position. Okay. And this is the same. All right. There's a lot of duplication here. It's really this. Is that the only difference? Vertical, vertical. Wow, it really is, isn't it? I don't know. Can I pass in a little lambda here that would do it? Pass in the value. Pass in the assignment statement. It's interesting that they happen sequentially, isn't it? Also, there's kind of a bias towards clearing out stuff above you compared to below you. Well, that's not quite true. You get 2 hits. That seems nice. And the ball changes. Excuse me. Oh, I don't know if. Well, one thing we could do, I don't know, this may be a bigger change than we want. One thing we could do is keep this in a vector, a pair, and then what you're doing is sort of an ordered pair. Now, unfortunately, vertical and horizontal, they are, well, somewhere they're 32. Horizontal is plus or minus 1. Vertical is plus or minus 32. So let's find vertical. Minus screen line distance. Okay, so it's initialized to that. Well, okay. I think that's probably a legit change. Maybe we want to focus more on this. I definitely see the problem is the old game was written with a keyboard in mind, and I'm playing it on a simulated iPhone, which has no keyboard. And really, I would like something more like a button that I touch, and when it's touched, it starts moving left, and when the other buttons touch it, start moving right. This doesn't really fit that model. So I want to do something that I don't know. I'd like to do something to make that more apparent. Okay. Let's see where's the scope of X here. Let's see. We read it, we compare it, compare it, compare it. We don't do anything with it after that. Okay, let's see who else references X. Okay, I think we might be able to get this into a local variable. Color. Well, that's not really quite fair, is it? Caller should be callers. All right, let's do it the slow way. Find X. Okay. All right, let's do let X var. Not even var, it is a let. Nobody ever resets that. All right, let's run tests. All right, while that's starting up, what I think I'm going to do, I really want to break this up into the cases, one for each letter or transition. And this, notice nothing happening here has anything to do with this stuff. All right, which means there's really no difference if I do it before or after. Okay, so that test passed. Let me do a little transformation. Okay, I did a little data flow analysis in my head. Where is horizontal referenced? Is it referenced at all in these lines? No. So no overlap in these two lines other than the +1, which is incidental. Okay, so this is equivalent. All right, now what I want to do is I want to pull out the case. All right, so if X equals this and paddle is that, is certainly equivalent to if paddle is greater than screen paddle min, then do this stuff in here. Okay, Control I. Control I. Where's my reformat? Reindent, Control I. Am I incapable of... Well, I gotta say, this does not look properly indented to me. Maybe I have to... Okay, that's better. All right, so I've made this change. If paddle greater than screen paddle min, then if paddle greater than screen paddle min, this is now redundant. Okay, and I'm going to do the same change again. So I'll start, if true, then do this stuff. We can't argue with that. All right, and now I'm going to copy this condition in. And I do it that way. It just gives me a smaller step. I really could run tests after each one of these, but I'm not going to. Okay. So now my structure is, if it's this character, otherwise, if it's this character, otherwise, if it's this character. I know there are otherwises because it can't be equal to all three. You know, I can only be equal to one at a time. All right, let me run tests. And I should have pushed before I even started this method. We had some changes in there. Okay, tests are running. You can see they're a bit slow. Characterization tests often are. And that's really because it's playing a whole game. I mean, a very short game, but it's a whole game. And there are delay loops built in. You get less and less delay as you take away bricks or blocks. Okay. All right, nice. And we'll commit. So we did some line cleanup. We did some rename. Made X a local variable. And we restructured if statements slightly. Not my best Git comment. I tried comment at the intent level, and that didn't really do it. All right. Let's see. What is this character? It's not an X. It's really, well, it's kind of the character. I mean, it's not really, but CH is better than this. Well, maybe it's keystroke. I don't know if I've used that name. Okay, apparently it's okay. All right. So I did a rename. Let me do a switch. Keystroke. Wake up there. Okay. And then I think we say case. Let's say case 127. Case. We'll put a break. Case 191. Break. Case 253. Break. And there's an else. I keep mixing up my languages. No, default. All right, I've been in Kotlin all week. Definitely a nicer Java, but it does have some slight differences. Okay. All right. So at this point, again, I have, I've made no actual changes, but I'm going to pull this up here. Okay. And this up here, 191 and 253. Okay. So my claim is these things can go away. They're already covered. Okay, so case 127. Let's keep the comment for now. And this one. Right, there we go. Run tests. All right, that passed. Delete the dead comment. All right, I'm going to trust my test run. So we changed if to struct. All right, so if the paddle is greater than the min, we move left. If it's less than the max, we move right. Otherwise, we jitter, and then we redraw the paddle. Okay. Let's see where move paddle is done. All right, up here. Hmm. Poke paddle. It's interesting. We're doing this twice, which means we're kind of doing some unnecessary drawing. We're only writing spaces. I mean, I don't know. It doesn't matter, I guess. If we don't move, we draw the paddle over top of itself. If we move twice, we end up drawing the paddle once and then erasing it and drawing it again, moved over a little more. My question in my head is like, do I want to pull this up? And then it's like move paddle, move paddle, draw paddle, move ball does the drawing, but it also is responsible for clearing. Yeah. All right. I think we'll keep it where it is. All right. So what's going to change? Well, let's get these constants. This is the keyboard row address, keyboard reader, keyboard address. Yeah, let me go with that. I don't understand why it would not extract that to a variable for me. It seems very, very simple. Say abstract closest convert to switch. Oh, there was a convert to switch? My goodness. All right. Let's manually extract. All right, what are we going to say? Well, let's call it keyboard address. Var key. It's really a let. Let keyboard address equal 57088. And I think I really can put that up here. Screen. Let's do that. A lot of constants. Okay. Keyboard address. This constant it's kind of like I'm thinking keys to look for. Keys to look for. The value was 251. And that's really a function of our game. It's not anything inherent to the memory layout or anything like that. Okay, so keys to look for is 251. And then 127, we'll call that key X. If I can type it, key X. And I guess I'll pull my comment up as well. And this is really not for goes to XC comma. Was that 191? ID. I don't need the comment here for sure. Okay. How's it looking? Well, once again, I want to pull out something. Like that. Well, even that is the only difference in these two. And this is like erase paddle. All right, so what I'm going to do is I'm going to come up with a constant. Let direction equal -1. And what? Never used. Okay. I'm going to add direction. I'm going to let direction equals +1. And add direction. Okay. Now I have two completely, literally identical things. Let's extract a method. This is clear paddle direction. Okay. And this is also clear paddle direction. All right, well, this is direction is 1, and this one is -1. Okay, and I'll move this down because I want to tell a story. Okay, so to move the paddle, you poke the keyboard address, you peek at it, you see which keystroke you got. X, you're going to move left if you can. C, you're going to move right if you can. Comma, you're going to do the jitterbug. I'll coin a phrase for it. Then we're going to draw the paddle. And boy, my sense of symmetry wants a draw method there, so let's do that. Refactor extract method. This is draw paddle. And again, I'll move it down. Okay, draw paddle pokes at an address and address +1. Let's see if that is used up here in the setup. I guess draw top. Draw initial screen. Oh, we don't poke the paddle until paddle. We don't put it in there until it's available. That's a little odd. It's probably an oversight, but we're refactoring here, so okay, these things, they all do paddle stuff. Next, we're around. Okay. The other thing I think we've done is I don't think X is used anywhere. Oops. Let's do this. Callers, none. All right, let's run tests. And they should pass. And that fact that the paddles are missing until the first time through the loop, that might well... I was going to say that might affect our test case if we've changed it, but it won't actually, because our test case is after the ball has already moved a number of times, so draw paddle's been called a bunch. So we don't have an intervention place where we stop it before the ball starts moving. All right. So that passed. Let's compare. Make sure I can describe this accurately. All right. So we pulled out constants for the keyboard related stuff. We used them, and then we pulled out methods to clear and draw the paddle. Okay. Keyboard related constants. Okay. Now, extract method to clear and draw paddle. That's kind of comment I like. I've got the reason, but I've got the mechanics of what I did too. Okay. We've been going a while, so let's take a break, just 2 or 3 minutes. I'm not quite sure what will be best to do when we come back. I think we'll play the game and maybe work on the UI a little bit. And there's certainly plenty of stuff to do in here. I'm not sure I know what I want to do, but it's there. Okay. And I do want to get rid of these constants or make them depend on the screen size. All right. All right. So 2 or 3 minutes and see you back then. Hi, welcome back. Alrighty. Let's run. And I do think this is kind of particularly horrid in the simulator, trying to do these buttons when we just don't have a natural model for it. Okay, you can see our paddle sliding 2 at a time. Stop there. Is that quite far enough? Okay. You can almost see it smoosh down to slide right. Oh, I better get moving. Oh. Okay, score 149. Oh dear. All right. So when I talk about the UI, like one thing is I'd like those blocks to take up. I'd like them to be more bigger, of more size. All right. The paddle. I don't know. Maybe there's like an M dash. Maybe would be a better character. Let's go over to the UI side a little bit. I'm not sure I totally love this either, but okay. Let's see. I think this is our character, and that's purely from like the OSI manual. Sorry, I forgot already. 135, I think, is only used for that. Yeah, paddle character 135. Everybody else is that. Okay, so let's see how a different paddle character looks. M dash, no. Control, no. Option. Okay, that's a little bigger. Maybe I'll check the spaces. I don't know. Will they have it like that? No. Dash. Who are you? Well, he doesn't go all the way across, but he's a reasonable choice. All right, let's take. Whoops. Take him. Okay. And I don't know, line? Low line, and he's not. Is he the full width of the character? Full width low line. That's kind of promising. I would rather have a high line for my paddle, but let's take that one. Full width high line. Well, he does not look like. Okay. Let's try that one. Makes me wonder if there's a left line and a right line. Vertical. Full width vertical line that does not look to be of the full width. These are all solid. I mean, it's kind of funny. Unicode did not pick up a lot of these characters that the old computers had, so we're kind of left faking it. I don't know what 25 CF is. Okay. Black circle. Let's put that here. 25A0. Black square. Now that I could believe there's a better version. I don't know why that says 2B24. I think that's the old one we used. Black circle large. What's the circle for? It's the ball. Well, I don't know. That looks kind of... Maybe it's too big. Okay, and let's try for more squares. Yeah, that's not 12. That might be better. Let's see. And that is 2B, 1B. See how it looks. The other thing is, I know there's space between the squares, and I don't know off the top of my head how to get rid of that better than I have. Okay, what do you look like? Now it's going to break our tests. Oh, he doesn't look very good. Yeah, I don't like that better. Let's take this one. Okay. How did our paddle look? Slightly better, but there's still space in there. Okay. Let's see. So this is adjust characters to better match. Adjust character choices to look better. Yeah. Okay. Now let's see what goes on over here. Well, you can see our 23s again, which represent 24, and you can see our offset 32. That really should not be visible there, I don't think. Okay, but what's going on is this is drawing our screen. So 0 to 23 is a row, 0 to 23 for the column, and then we put a character out for each character in the screen at the given position. All right. That definitely could be better. But what I think we're seeing is there's a lot of space horizontally, at least. Vertically is not so bad. Oh, look at that little something that character got chopped off a pixel compared to the others. Isn't that kind of annoying? All right. Notice there's a little pixel up top. That we can see, and then it goes below its baseline a hair. Interesting. I think I tried stuff like dot padding 0. And I don't know, there's something in my brain that does not want to remember like padding and inset and what are all the choices there. I mess it up in HTML all the time or CSS. I'm sure I can mess it up here. Okay. So let's see what our stuff looks like. And I've changed back to the other block, so we'll have to just remember way back. That seems like a lot of space there. I mean, it's got almost as much space between the characters as it does kind of horizontally. Give it a glancing swipe. All right. Let's see. We're going to have to do a little bit of searching around, I think. Let me get a window. Yeah, before we started today, I don't know, my Safari just would not stop spinning a beach ball and blocking everything else on the system. All right, so Swift UI. Remove padding. Remove horizontal padding. H-stack, Swift UI code example. That sounds like what we want. Okay, I can put it on the H-stack, spacing 0. H-stack. Spacing 0. Now this spacing stuff will not affect our tests because they're looking at what are the contents of the screen, not how does it look on the after we've mapped it to the visible screen, just that screen object, what's in there. Okay, so oh, that looks tighter. Oh, yeah. It's smaller, and my edges are funny. But my horizontal line looks really good. You can see the space drawing it out. The drawing's a little ugly. Boy. All right, and these side walls are not the same as those side walls, but I'm happier. I can probably magnify this thing somehow. Let's see. So that's back to our characters. The sidewall. Well, let's see what they are. 136 and 143. 136 is the right wall. 143 is the left wall. And then what happens down here? Draw the sides. 1 to 23. So we're not drawing the top row. Well, that's weird, isn't it? That's clearly a different character or positioned differently. It was like that before it printed, right? Let's make another character so we know they're the same. Let's see, vertical bar equals, what are we going to do? Let's take this. Oh, these constants. Now, again, it would be nice if I had a little sort of airplane dude. See if we can find something. I don't think there is. They have a plane, but it's not. Yeah, it's not suitable. I could probably rotate this one. I don't know, but really, I want a rocket. And again, like if they had drawn it vertically or horizontally, I could do something with it. And let's see if there's any math symbol that looks better than a V. Shouldn't be too hard. Well, flying brick. That's at least interesting. That's not a bad. Ooh, that would be nice. Is there a vertical version? Well, there's that. Okay, what was my best choice here? That's one choice. No more. That one's kind of like, whoa. That one's nice. It's got a little trail. Let's see how it looks. Oh, maybe the one two over. Five, 6, 7 rows. Okay, the original drawing. Oh, I'm not even using that thing. Okay, let's put it back. This game doesn't even use 238. All right. What the heck is going on? Why is the paddle? So writing the paddle messes up that. The paddle must be too wide. Let's see, moving it doesn't. Yeah, when it blanks out, the thing goes back. Okay, this is. Let's see. 128 is the top wall. What do we got? think we did line. Full width low line. We don't want the full width low line. Can we just get a low line? How's that one? Okay. Well, go the same. Okay. See if that does better. I keep thinking, oh, we're going to break the screen check, but no, that's not supposed to break it. It definitely would if it were taking a visual snapshot, but we're not doing that. We're taking a snapshot of the screen memory with no control over how it's drawn. I think I can probably put a spacing in the... oh yeah, that's much nicer. There's a little space between the two halves of the paddle, but I think we'll live with it. Notice it kind of bounced in the air. I don't have a line. Well, maybe I do. Is there an overline? Over. I mean, there is in Unicode for some macron. It's combining character, combining. Oh, that's kind of nice. Those are probably combining, no? Well, can I combine it with a space? This is the paddle. Right, 135. Paddle. I don't know if it combines before or after. Interesting. It doesn't show the space there, but... All right, let's try again. He's not very high up, is he? All right. So we're adjusting the look when the paddle gets hit. And I really would like to fix that blanking out aspect. Oh, man. Hit, slide down, go across, slide across. Yeah, that, what's that called? A macron? Combining along overlay stroke. That's really the one that's up there. All right, let's try that. And what's this one? Overline, combining overline. Oh, I don't need to. I've got an overline. Okay, plain old overline. Run. I like it. There's still a slight space between the paddle, between the two parts of the paddle. Oh yeah, that's definitely better. Okay. Let's see. So we've improved the view, better characters, less horizontal space between characters. Okay. I'm okay with this. All right, so let's do a SwiftUI magnify view. Magnify view. Scale, yeah. Once again, we're on Paul Hudson's site. Scale effect. Scale effect 2. All right, and I think we can put it on the VStack. I guess maybe after this would be better. Two's too big, but let's see how close we get. And really, I probably ought to, get my screen and divide it by something. And yeah, too big. Too big. Okay, but 1.5 looks like it'll be just about right. Maybe 1.7. 1.75, just keep it binary. I want it small enough that my keyboard command, my keystrokes still show up beneath. Oh, that's not quite. Okay. 6. Sorry. Go. Close. If I just had less space between the command and the go button, I think I might do okay. Less space between the command and the go button. That's horizontal. This one, can I put something in here? Min length. Dot max. No. Well, let's do this. Scale effect 0.5. Not quite. Let's see how bad it looks. Still over that. Probably too much. No? Okay. Interesting. Alrighty. I don't know how to make. Well, we'll do that. Now, I think part of the issue with like the giant square and so on, it's because I'm doing this as simple text entries on the screen. If I were to like force their positioning instead of drawing them generically, then I think it would be okay. I would call it just acceptable. They're a different color, that helps. All right. Okay, so let's see what diffs we have. I think we just adjusted the spacing of this thing, right? We tried a little bit down there, a little bit up here. I'm going to take this spacer off and see what it looks like. Well, I don't think it made much difference. Some, yeah, a little bit. Okay, and let's try one more thing. Again, I think I'll live with that. But I think we could try the same trick on here. Let's try spacing 0 and see if the little extra bit of squeeze on the characters is worth it. Our blocks might be more monolithic looking. I don't think so. I don't see. Yeah, I don't. Oops. Okay. All right. Let's take what we got here. All right. So we adjusted spacing and scaling to make a slightly bigger screen play area. All right. Man, I'm so tired of seeing 23s and 22s and 24s. This really ought to come from the environment. Do we have the environment? We do. This is just some... Oof. I mean, that's... It's that 53381, 53248. Let's see what those are. We'll have to go down here. 53381 is the top of the visible area. And 53248, I think that is the top of the actual screen memory. Those are definitely environment numbers. All right, so we'll have to see if we can get those in the environment. Let's see. So I don't know, this character stuff. It certainly doesn't belong on our. It shouldn't be part of our game. This is really, I think it's an environment thing. Okay, the wind is really blowing here. It's an environment thing, and we have to be a little careful. I don't know, maybe I give you some way to override it, but I think my basically library that we're pulling in really maybe should support the characters as string characters, and maybe even define the values in a useful way. Oh, and one more. I keep wondering if there's a medium-sized circle. Okay. Well, he's kind of medium-sized, if you don't mind the dots. That's the one we're using. I don't know if we could say medium circle. Nothing. I mean, that's too small. Wherever the one that corresponds to this seemed like it's too big. Oh, it was that one. Black circle is too big. Notice it goes outside the guidelines. I mean, it hangs over like a J, a lowercase j. Is this smaller? No, that's not. That fits completely in. Why can't I get one that fills the area? I could give it a bigger font. I don't know. But at any rate, I think these characters probably should come from my basic environment support. And these 22s and 23s and 23381s and stuff, 53381, definitely should come from there. All right, so we'll take a break, 2 or 3 minutes again, come back, and let's get some environment-specific stuff out of our code here and referenced more appropriately. All right, see you in 2 or 3. Welcome back. All right, so I think several things I would like to happen. One is I would like to have names for these things. And somewhere I have the OSI documentation. We can go see. I don't think they give us names, but they do. They do give us a drawing that we can go from. All right, and can I do that? How can I best do that? Let's define the things in here. And I think I'm going to call this char set OSI. I don't quite know if that's the way to go, but I want to give it some constants. Okay, so let's find that documentation. Can I get to a finder? All right, let me do this off screen a little bit. Okay, so OSI characters. This is a reference manual. Somewhere on my xp123.com, there's a link to it. A recent blog article that detailed both these files. Here's that keyboard matrix, but we're interested in the character set. All right, so our characters, I think we had 128. 128. Let's get down there. And, you know, I think in the long run, I think we really ought to produce pixel level exact pictures. And these maybe should be little views. What would that look like? Okay, well, let's do it as constants for now. Okay, 128 equals, oh, well, let's see. Something equals 128. It's really the situation. I'm going to say charset.osi, and I forget, do I do const? Const. Let. Maybe it's const name equals. This is, what is it? How do we want to describe this? I want to say 1, 2, 3, 4, 5, 6, 7, 8. Maybe like row 8. 7, 6, 5, 4, 3, 2, 1. Column 1, 2, 3, 4, 5, 6, 7, 8. column 7, 8, or row 7, 8, row 1, 2. Okay, let's try that for now. So this is row 8 is 128. Is that right? Okay. 135 is row 0. Row 1. I'm mixing up my numbers. We will see. Is that correct? We start on the bottom and work our way to the top. Okay. How do we want to do these? So yeah, let's keep going. 136. That's column 1 in my naming convention so far. Call 1 equals 136. And I don't know, call me crazy, but the order just seems bizarre. Okay, I guess I gotta look up a Swift constant. Do I just do let? I guess so. Naming constants. Yeah, just let. Okay. $143 is going to be column 8. $161 is a square. Maybe I ought to call it. Maybe square black. I don't know. Row call 1 to 8. Well, we'll go with square black, I guess. Ball equals 226. All right, and that seems a little, well, a little contrived, a little wrong. All right, I think we don't really commit to what it is. Let me see. Let's look at 238. Where did you go? You're already on that document. Okay. Down a ways. Yeah, so there are 4 planes. You know, be nice. Okay. Let's go back to Xcode. All right, so one thing I can do is I can say char.osi.row8, I think, for 128. Is that going to be happy? Let's do a build. Int cannot match value of uint 8. These are uint 8s. A value of this type instead. Instance member. I don't know if I do this. Yeah. Okay. I don't know how this is going to play out. And in my long run, I want the environment to be substitutable. And so you should be getting a constant from somewhere else. Maybe there's a char set class, I guess. And OSI implements it with a mapping or something. I don't know. All right, but if we had this class and we had this function, let's get the values in. 135 is row 1. One 36 is call 1. Call 8. 161 is square. Ball. And plane. Okay. That should be okay. Now if I take this, I'll do it the slow way. Let me copy it. I'm gonna need this. Okay, because people use vertical bar. Okay. Okay, that seems okay. And now this thing should be able to return charset OSI dot 2-character value. Okay. All right, should that be attached? Maybe a character set is its own thing. It's big enough. All right, now let's see who calls this thing. I believe it's only there. Okay. I don't think I can just define it here, unfortunately. Can I do that? I thought it was going to choke. Huh. Okay, let's try this. Do character. Okay, let's make sure that runs. All right, it looks like it's the same characters that we were hoping to draw, so that's a good sign. We'll let the paddle and ball get out there. All right, I think that looks good. Okay, so now the big step. See, in a way, what I want to do is say, give me... Well, what I want to do... People give me integers. I just want to ask for a 2 character value. And this thing, there's only 256 choices, so it'd be easy just to make a big array and return the value in the array. And actually, the better thing is probably to return the view, the text object, and let this be kind of a view thing. I don't know. We'll have to think on that one. But we can move this over. Okay, so I'm going to move class charset OSI. We're going to move it to the other project. All right, now this is basically... All right, so I'm saying there should be a new file. Swift file, charset OSI, and I'm just going to put the class in there. Okay, so now somebody can create this thing. Again, I don't think this is the long-term ideal solution at all. Oh, we get the letters for free with this. That's why we did it. Okay. But that feels useful to this endeavor. Okay, and that's all these things. Charset OSI. All right, 2 character. I believe I could call charset.2 character down here. Let's effectively inline this. Charset.2 character. Get rid of that completely. Make sure it's good. I'd like to do something that's... I would really like to pull out keyboard, character set, screen. Like all these things are independent. There are multiple models of these computers, and you might need the 64 by 32 screen or the 24 by 24 screen or whatever. Right now, that's all an environment, and it knows stuff. Okay, let's see. This, I'm gonna try and do a couple of things at once. Let's make this public. What's going on? Oh, I'm in the wrong one. Okay, that definitely makes a difference. Okay, these constants I think are useful. Screen start, screen end, visible screen start, visible screen end, visible count, and screen line distance. Screen line length. All right, let's keep it. Okay, these weren't exposed before. Now I'm going to expose them. So let's run our tests here. All right, so my plan is I'm including the OSI character set class that we wrote for the other one, and I'm exposing some constants that we're going to use in a minute. And assuming these tests pass, which there aren't all that many. Okay. I'm going to treat this as simple enough. It's a bunch of constants and a bunch of mappings. Yeah, some stuff won't look right. Okay, but I think that's a future issue. At some point, I would like to, instead of returning these predefined characters as strings, I'd like to return little text views, actually little views, they're probably more like images, that are 8 by 8 pixels and map directly to these pictures. Okay. And I don't think that's, I think that will be helpful. All right, these tests all pass. Okay, so we're going to commit. Let's see. So this is made screen constants public, added char set OSI. All right, I'm not going to push it just yet. In here in Git, I want to re-tag it. Okay, current is up 1. We'll tag that. And this is 0.0.14. Get off that Friday the 13th vibe. Okay, and push, including tags. All right. So this is a Swift Package Manager package. So I'm not sure what makes it known to be one, but in any case, I'm just pushing it up to my private Git, up on GitHub, and once it's pushed, we will update the package manager on the other side and use the new version. And I don't know why it's slow. It shouldn't be any slower than it is to send stuff. And I can see I'm still broadcasting, so I'll take it. All right. I'm going to grab my drink while that's running. Be right back. Well, this is discouraging. All right, I can see GitHub. Okay, it appears to have done its job. Now we go down here and update package. All right, that's done. Let's go over here and use it. So we should be able to remove this. And I'll just comment it briefly. We'll keep that. I'm going to do a clean build and run. And we are hoping, yeah, why aren't you finding it? Import basically charset OSI. Xcode's got things going for it, but I don't know. Can't tell if it's going to be happy or not. Failed to produce diagnostic. Well, what can we do? Clean finished. Clean build folder. Run. Cannot find its scope. No such model. Basically. Right, and if I say import B, how about basically module? Okay, let's try it like this. Build. No charts at OSI. Failed to produce diagnostic. Cannot tie and type basically. Okay. Oh, do we make it public? I'm terrible at that. Okay, we did not. Everything you want exposed in this has to be public. All right, all those functions are now public. That's good. And I'm trying to make myself do a little work in the README every time. Okay, so let's see. Char set OSI. Defines constants for each character it supports, character, and it also has make sure I spell it right. Something like that. Okay. And maybe one more for the debt we've been accumulating. All right. What do you have to do? All right. And I don't know that error. I guess we'll leave that part out. And I never remember markdown. Like, what was it? Backticks? Okay, that's one tick better. Run tests. We'll get this built in, make sure it works, and then call it a wrap. All right. Commit. Update readme, make char set OSI, and its functions public. We'll tag it. And push. Hopefully faster than last time. Yes. Okay, update over here. Update package. Failed. What happened? Did I not push? Oh, I didn't set my flag thing true. All right. Push. Include tags. Is that going to work? Back over here. Update package. There we go. All right, we're making progress. Let's run tests. Internal protection. Oh, I got to declare a init. Oh. Ah. opposite of helpful. Okay. Okay. Did I make it public? Yes. Okay, so that seems good. Let's tag this. Why is it not picking this up? Okay. All right. 16 is the latest, right? Run this again. All right, so it appears like it built and it's running. It's got characters, so I'm not concerned. We can take this out. Okay. So I believe that'll do it for today. We're going to, I'll check that in as soon as we finish here. Next time, let's get rid of all these 23s and 24s and 22s and these weird offsets. Let's make sure that the basically package defines all these addresses that have some significance, including that keyboard one. And we'll go back to refactoring on the game itself. I think it was good to improve this, but I'd like to get back to the other. Okay. And well, I'll let that finish running offline. Oh, there you go. All right, so thanks for joining me today. Next time is going to be Sunday afternoon, 1 to 3 p.m. Eastern Time, and hope you can join me then or in the future. Take care. Bye-bye.